This is the Significant Figures video. After reading the text and watching this video, you should be able to do two main things. The first, you should be able to look at a measurement and determine how many significant figures there are. And second, you should be able to perform any math calculation and round your answer to the correct number of significant figures. You might want to pause the video on this slide if you haven't read the textbook, specifically looking at page 47. There are a set of rules for determining how many significant figures there are in a number. So either pause the video or turn to page 47, because on the next slide, we are going to look at some sample problems to determine how many significant figures there are. Make sure that these problems are in your notes when you come to class next time. So we're going to quickly go through these. All right, as you know from the rules from the previous slide or from page 47 in your textbook, if we look at problem A, 875 grams, any non-zero number is significant. So when we write down how many significant figures there are, we can just write it to the side and we can either abbreviate it SF, or if you want to write it out as we say it, you can say sig figs, because each of those non-zero numbers is significant. Letter B. Now we get into the problems that contain zeros. These are the more confusing problems. But letter B is really easy because any zero that is in between two non-zero numbers is significant. So we have 1, 2, 3 significant figures in letter B. Now the remaining three, you're really going to have to look at those rules carefully. Letter C, 2.00 milliliters. As you can see from the rules, any zero that comes after a non-zero number and after a decimal is significant. So the 2 is significant as well as these two zeros. So there are also 3 significant figures in this measurement. Letter D. These are called leading zeros. And notice there's no number, there's no non-zero number in front of it. So none of those leading zeros are significant. The only number that's significant in this measurement is the 4. So there's 1 sig fig. Letter E also contains some leading zeros, but it also has a 0 after a non-zero number. So both the 4 and the 0 are significant in letter E, which gives us 2 sig figs. There are some additional problems on page 47 with the solutions for determining the number of significant figures. So if you're still struggling with the rules, you might want to turn to page 47 and do those 5 problems and bring those to class as well. When you come to class on Monday or Wednesday, whichever day I see you, we're going to go through a shortcut. But I'm going to save that because you really need to understand the rules before we learn the shortcut. The second goal of this video was to show you how to round your answers to the correct number of significant figures. And we have 2 sets of rules, one for addition and subtraction, and another set of rules for multiplying and dividing. So let's start with addition and subtraction. When we are adding 2 measurements together, so let's say we're adding up 2 masses together. Let's say that these are grams, 14.0 grams plus 8.115 grams. When we are adding or subtracting measurements, our final answer must be rounded to the least precise place. What that means is we're still going to add up the number the same way that we normally would. So if I'm going to add this number, that's going to be 5, 1, 1, 22.115. And in the past, when you type an answer into your calculator, you would just write this whole number down and report your answer that way. But notice that the first measurement, 14.0, is only precise to the 10th place. So what that means is we actually need to draw a line to show where our precision must be. So our answer has to be to the least precise measurement, which is the 10th place. So this big long answer that I have has to be rounded to the 10th place. So my final answer that I would report for this measurement would be 22.1 grams. Notice I've rounded my big long answer to the least precise. This can only go out as far as the least precise measurement that I'm adding or subtracting. The second set of rules is for multiplying and dividing. When I multiply and divide answers, my final answer must be rounded so that it has the same number of significant figures as the measurement with the least number of significant figures. Makes more sense if we do a practice problem. So here we have three numbers that are going to be multiplied together. 2.1 times 4.89 times 18.21. So you still multiply those the same way that you normally would. 2.1 times 4.89 times 18.21. And when you type that in your calculator, you get a big long answer, 186.99849. Okay, but we need to round that. And if we go back and look at each of our three measurements and see which one has the least number of significant figures, this one has 2 sig figs, 3 sig figs, 4 sig figs. So I need to round my answer so that it has only 2 significant figures. So the way that I do that is I start on the left-hand side of the number and I start marking which ones are going to be significant. So my hundreds place number will be significant and my tens place number will be significant. So how do I round 186.99849 to the tenths place? Well, you guys know how to round. I'm going to look at the number right past the tenths place and the ones place and make a determination how I'm going to round. Since the 6 is greater than 5, this answer is going to be rounded to 190. This would be how to round your answer when you're multiplying or dividing measurements. You round it to the least number of significant figures. These are very strange at first. If you need extra help with rounding, take a look at your textbook on pages 48 and 49, and there are some extra practice problems there. But when you come to class next time, we will go through the shortcut and we'll do many practice problems.